We're going to look at functions now from the point of view of a mapping notation. Now, mapping notation just is a fancy word of saying, two things are related by using, like an arrow, for example. So in this case, a Civic is related to a Honda in some type of way. What we have here in this first chart are some examples of functions using mapping notation and non-examples. So in the case on the column on the left hand side, you'll notice that all the elements in this set, Civic, Accord, Pilot, they all map to Honda. Okay, if I look at numbers in this case, I have the number -2, -1, 0, 1, 2. They also all map to numbers. Keeping in mind that the number 1 has both let me do this a little bit smaller. Number 1 has both the number 1 mapping to it as well as the number -1. Okay, so two different numbers going to the same number, and that's still a function. Another example over here at the bottom, we have 45 goes to 0, 21 to 5, and 22 to 1. Now non-examples would be when you have 1 over here, for example, the Honda, going to two different things, or two or more different things. Okay, so this would be a non-example of a function. Over here, we have the numbers, it's a bit condensed, but you can see the number 4 goes all the way up to the number 2 and also to the number, -2 and also to the number 2. And same thing in the last one. Okay, so this is not a function. Okay, same thing. 21 goes to both 0 and 1. That can't be the case. And you can look at the ones over here on the right hand side. All of these in this column are functions, and all of these in this column are non-functions or not functions. By the way, you might want to notice that the last one over here goes the opposite way, but still the same idea holds. You can't have one number going to two separate things.